Safir. Everyone, I'll be here in the back end. If you have any questions or any technical difficulties, please use the chat window. Okay. Thank you so much.
Got it. All right. Thanks a lot, Shrijas, for the intro and for everybody in the room. Right. Glad to be here, and it is always a pleasure to work with the community and try to help out each other. Right. Not about me helping somebody else. It's all all of us coming together and sharing the knowledge. I don't know. I will take away something from this meeting. You share something that I don't know. Right. So this is about a give and take. Right. And I'm really happy to be here. We have 15 participants now, including us. So, is that good enough, Sridh? Shall we move on, or do we want to give?
Yeah, we can continue, Safir. I think.
Okay.
Yeah.
All right. So, just given that this is not a regular Zoom meeting, right? So, participants can unmute themselves, right?
Right. All of them can actually unmute themselves, can be on audio, video, and all. Yeah.
Okay, so why not we just start with a question back to the audience, right? I know I am supposed to give the container 101, right? But for anybody in the audience, somebody want to attempt a very basic definition of. I'm not looking at the detailed discussion, but tell me what is container to you? What is your thought about container? Anybody?
So this is going to be an interactive workshop, folks. So, I mean, there is no stupid responses or stupid statements. We are all here to learn. So please feel free to share anything which you think about containers. It may be right, it may be wrong, but feel free to respond.
Yeah. See, there is nothing like wrong answers here, right? We are all here to learn, right? I might make a mistake. I have made mistakes in live training sessions. Trust me. So not
Yeah, so containers are like say some box or something, so we can put stuff inside those containers, so it will contain something like that. So
okay.
so we put some our application in a container, so that container will provide the functionality to run it properly.
Got it. It's 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 definitely that that's just part of the definition. Anybody else want to attempt anything? And thanks again, Ajit, for that.
It is like a package which contains all necessary softwares or environments to run our application.
Okay, thanks, boss. Cool.
Earlier, we used to use virtual machines, but containers are way ahead in terms of security and with basic imprint, with little even up to 17 KB also we can install a software application.
Correct. Got it. All right. Anybody else? Cool. That is fine. With your permission, I'm just going to take a sip of water before I continue. Give me a second.
Yeah, Safir, your voice is at times a bit low. Okay.
Say that again.
Times. Yeah.
A voice, right? The display is fine, no?
Yeah, it's fine. It's fine.
Okay. I will speak. I was I think my voice went down a bit. Now it is audible, right?
Yeah, it is. Yeah.
So thanks everyone for those answers, right? Whatever all of you said is rolling up the definition of container, right? It has some sort of isolation. It's for running your application, and there is a lot of optimization as compared to virtual machines, right? But again, see, we can have a very big formal definition with 5-10 sentences, right? But let's put it this way, right? At the end of the day, container is an isolated process, as simple as that, right? It's a single process which is isolated to begin with, right? That is the fundamental definition. Now, that concept is not something that started day before, today, yesterday, or even when I'm sure most of you would know Docker as a synonym for container, right? But that concept started long back. I'm pretty, of course, as Srijit had mentioned about my experience, me, Srijit, and all are a bit old, in this field, right? So even before we started, there were concepts of things like BSD. You might have heard about the operating system called BSD, right? BS has this concept of jails, where they can jail a process so that it can be, its access to the rest of the system can be limited. Now Linux took that up. There were concepts like C groups and namespaces which could does this kind of containing the ability of resource to or as process to interact with the rest of the system, how it can be controlled, right? So that was the beginning of this concept itself. Now, why did virtual machine come into existence? There in the beginning, there were only hardware machines where servers where you could run your workloads, right? Now, what over the period of time people figured out is how much ever good machines you buy, how much ever you optimize, there is always going to be periods and cases where most of your system might go unoptimized because you are running a web server on one big 16 GB, 32 GB, or 64 GB kind of server, and you have another database server on a couple of other machines like that. But rather sometimes your application may not need that much resources, but given that you are tied to the hardware, you are always stuck with that much of resources, right? Now comes the concept of how do you optimize it? To start optimizing, we need to be able to allocate part of the resources dedicated to some process. And that is where the concept of virtualization started coming up, right? We will have VMs, which is actually running on a hardware. You can have multiple VMs packed into the same hardware, right? And any customer, any user can pick up whatever VMs of their configuration, right? Now, basically what happened is this much resources were open. Now you can restrict that into a smaller size of resources, right? That is what VM gave you, and it gave you full control because at the end of the day, whether you are accessing into logging into a VM or a Linux and a hardware machine, doesn't matter. It's all the same, right? You get the same operating system, you have full control, you can do whatever you want, right? So that is not an issue at all. So that is where we started that optimization. Now came the next part, right? What was that? It was about how we will further optimize. Optimization is just one part, right? The other part is about isolation. I want to run a workload. It has its own dependencies. This process, has to be what do you say, secured from other part of the system, things like that, right? So there are multiple concepts or parts of this thought process that came into existence, and people started again, as I said, BSD jail was there from the beginning. After some time, Linux started introducing something called C groups. C groups as version 1 and 2, and there were concepts of namespaces. Right? We will briefly touch upon what are all these things. But basically, the idea is these concepts are always there, and people are always trying to figure out what is the technologies that can keep process optimized and isolated. One for security, the other for having a pristine environment for that application or the process itself to run. Right now. When Docker came along, it became popular. But even before that, I don't know how many of you have heard about Ubuntu LXT, which is still a container technology that is still popular, and Ubuntu, the Ubuntu team basically promotes it, right? So these concepts and these toolings were there, but Docker is what really made containers popular, right? To the extent that if somebody says container or container image, we are just going to use it as we are just going to say, okay, Docker container, Docker images. Nobody talks about container as a generic thing. It is Docker. That is the way it's synonymous, right? That is the way it is. And why that happened, thanks to the Docker company and the Docker community, right? It became popular. They gave a very effective way of tying everything together and presenting it as something as a container, right? We had all these technologies that I mentioned earlier, right? There were namespaces, there were concept of C groups, things like that, right? Now, what happened again? Let me just briefly touch upon what are these things, right? I keep repeating those terms, right? Namespaces. Namespace, what it gives you, this is a Linux concept. What namespace gives you is you run a process, right? Ultimately, what we want to do, we want to run our applications or process, right? Now, what namespace gives you it? A process can consume its own process namespace, processes. I know running the process, right? That is one thing. It would consume other resources, memory. It might need a network access, right? Now, what happens is for these kind of things to isolate some part of the system resources in these spaces, right? The namespaces. Let's say network namespace. You want to have your process should be having network access, but nobody else should be interfering with the network. To do that, you needed network namespaces. So like that, there are a bunch of namespaces in Linux that were used to do this isolation of processes. Similarly, there is something called control groups, C groups, right?
Yes,
now,
sir.
control groups. Was there a question?
Yeah. Can you explain with the example? means with relating to some applications like that.
Can you please repeat the question again? What has to be explained?
With the
Hello.
Husni, your voice was breaking when you said explain what. Can you repeat, please?
Explain with an example, she meant.
Okay. The namespace or maybe namespace.
Namespace with an example?
Yeah, I think we are. I'm just guessing that. Yeah.
Okay, see, at the end of the day, Linux has a standard set of namespaces. One of them is, again, as because network is easier to, explain. That is why I said, network namespaces. There are mount namespaces. There are, a bunch of other namespaces, right? Now, what was happening over there is, let's say network namespace. Let's say you can define a network namespace. Okay, it's just a definition. Think of, forget about what exactly it is. Say that you can define a network namespace in Linux. Okay. Now, what happens is you have a process which is running, in your system. Now that is a, let's say, a web server, to be, to the simplest terms, right? You are just running an Nginx server, right? Now you want the network access of that service to be separated out and kept separately, right? It will still part of the system, but you want this process to think that it is, let's say it doesn't have access to anything else, whatever it is seeing as a network space, that is the only service that is running on the machine, all right? Now, why do you want to actually do that? So that, let us say, if the process is trying to access something outside of its, power, or either by compromising or, by mistake, that shouldn't happen. So it's again, ties back to the concept of jail, right? Jail, BSD jail typically was only about, controlling the process or the, process namespace. Network namespace is about control the network. Let's say let's say this Nginx, if it has to work, right, it has to have a network access, internet access, right? Now for that to happen, in namespace, what happens is within namespace, the Nginx process will see an interface which is not visible to anybody on the other side of the system. But the namespaces manages to create a pair of virtual interfaces. One side of the virtual interface is inside the namespace, which Nginx can see. On the other side of the namespace, there is an interface which is connected to the system. So with that, what that facilitates is Nginx can talk to the system, but when Nginx looks around, it sees that there's an interface, but nobody else is there. It cannot access anything else on the system. That is the way, the access is controlled. That was the whole idea of namespaces. Similarly, let us say you want to mount something. You want to make a directory available to somebody, but you don't want to this, let's say this Nginx itself, right? You don't want it to be accessing anything else on the system. For that, you have to cordon off and secure that part and only expose that particular directory to the process. That is a mount, that is mount basically, right? So like that, there are a bunch of namespaces. Okay. Now, similar to that, again, control groups, right? Now, when it comes to control groups, it's about controlling the resource usage of a process. Namespace was about controlling the process itself, what it sees, defining secured or limited area of resourcing for that process. Now, C groups is about how much of that resource this process can use. Let's say you want to restrict your process. Let's say your machine has 16 GB memory, but you know that your Nginx only needs 1 GB memory. How do you control that? You put that process inside a C group, a control group, and enable memory accounting and set a limit, saying that okay, this process can take 1 GB of memory. So as far as Nginx is concerned, it sees 1 GB of memory and it can take up to 1 GB of memory. So even if the system has 16 GB, 15 GB of memory left, this fellow only sees 1 GB of memory. So that is the concept of C groups, right? So Docker, what it did is it combined the concept of namespaces for controlling, isolating the process, C groups for enforcing the quota on quota of resources that a service can process can use, and they also used the concept of union file system, which essentially is what you see when you are actually using Docker or container images. Okay, so they put all of them together, made a tooling and system around it, so that for you to run any process, there could be an isolated environment which provides a dedicated resourcing in terms of network isolation, process isolation, disk isolation, and everything. And at the same time, also giving you the ability to control how much resource from your system can that process take, and also how to manage the file system. So this is what Docker gave you basically, right? Now, that is where like the explosion or like what is the revolution of like the container basically started. Okay. So that pretty much is about like the history of like how container came to being, right? Now, I'm assuming all of you have used container in some shape or form, or is this the first time you are hearing about or like talking hearing about the container? It's okay if you can just mention, because I want to know like if I have to further explain the whole thing, or we can move on. Any questions also, please, feel free to ask.
Yeah, any questions on containers? Safir was asking, are you already working in containers, or are you, what is your current level of experience? If one of you can actually answer, that would give us an idea about what level of experience you have.
Yeah, when we say experience, we are not looking at exactly what we did. Even if you have done like just spawned a Docker container, used an image or whatnot, that's what we are asking for.
Right.
Nothing more than that. So just to understand, if your knowledge is a little below that, it is totally fine. I
I
would
just
add
started
additional
working on
explanation.
Docker. I just started
You have started?
working on Docker.
Okay.
Okay, yeah,
Docker
that's
container.
totally fine. Which means you understand that there is containers and images, right? Because that is where we are going next, right? So anybody who has not see what I explained right now is the history of like containers and how the container internally works to a point, right? Again, in the interest of time, limited way, right? Now we are going to talk about containers themselves and like container images. So if you are all good with that, like we can just move on to that, or if you have a question, feel free to stop me now and like ask the question.
We would like to know more on container images.
Can you please speak up? I don't know if it's my headphone problem or.
Yeah, Girish, we heard something, but can you speak a bit more louder?
Yeah. Like we want to know more on container images.
Correct.
Images.
Yeah. So okay. Yeah. Got it. Yeah.
Yeah.
So we are coming to that, right? Now
Okay.
we talked about all this. Again, anybody else has any question? Because anyway, we are going to container images. But before that, anything I talked about already, or like anything else that you want to ask? All right. Again, like there's a chat actually, I believe, right, Srijit?
Yeah,
You
so
can
I'm
put a
responding
chat.
to it. I was saying, when you actually do the demo, probably that would give a bit more explanation of what it is and what container images are, right?
Got it.
I'm
Got it.
responding to Husni right now.
Okay, cool. Yeah, so if you know your voice is not clear, or you missed out something, even like half an hour down the line, you can ask the same question. It's not an issue, right? You please put that in the chat so that you don't miss out on the question, and we will get to it. Okay. So I'm just proceeding with rest of the section, right? So before we start, kick off the demo, right? Two things to start off, right? Again, I gave an idea about the internals of what containers would be, right? But see, at the end of the day, what are you trying to do with a container? To run an application, right? At the end of the day, I want to run my application somewhere. That is my objective, right? As a software developer or as an engineer, that is going to be my final objective. There is some echo coming. Is there anybody who is not muted? Sorry.
Yeah, Ajay. Okay, it was, yeah.
Okay, thank you very much. Okay. Well, let's see. At the end of the day, what do you want to do with containers? Containers, technology, C groups, namespace, everything is well and good, but why? All right. The fundamental idea is that at the end of the day, VMs, hardware machines, Linux, Windows, container, whatnot, we want to deploy our applications, right? And the idea is that we want to do it in an efficient way. We want to do it in a way like that where the resource is isolated and like is not meddling with somebody else cannot meddle with your process, and your process cannot meddle with something else on the system, right? That is what we want to ultimately do. That is our purpose. What we are using is the next part of the question. This is our objective, right? At the end of the day, you have an application which you want to run with certain amount of resources, which it doesn't over consume any resource from the system, and there is no breach of access, so that this services or your application is kind of like protected, right? Or others are protected from your application also. That's also a concern, right? Sometimes. right? So that is the whole idea of objective. How are we going to do it with containers, right? We talked about all these namespace and control groups and other things. Now, let's say for the containers, right? How do you deploy an application without them? Let's say you are on a Linux machine, right? What you are going to do is you are going to basically install a package. Let's say just a simple Linux, let's say Ubuntu machine or a Linux machine, Red Hat machine, right? If it's a Red Hat machine, you are going to do RPM install, right? You would probably use a package manager, which will, where you can say yum install. If it's on an Ubuntu, you will do apt install. Let's say Nginx, again, I'm just coming back to Nginx as an example, right? Apt get install Nginx, or yum install Nginx. That is what I'm going to do to install Nginx as a service for me, right? Now, what does it do ultimately when I run this command? It actually goes someplace, downloads a software which is packaged in a particular format, brings it into your system, extracts all the files from the. So at the end of the day, a package essentially is in the format of what do you say, an archive, tar, gz, zip, whatever, right? So it brings that archive, puts it on your system, extracts it, and then start a process. Put the configuration or the files in the right place in the system, and that is what a process, a package installation does, right? Now that is how in the base machine, the VMs or bare metal, Linux, what you say, the hardware machines, your application runs. Now we are taking it up the containers. What happens is something similar to that. At the end of the day, whatever you intend to run as a software, that software has to be somewhere, right? In some form of packaging, some form of an archive. That should be retrieved and put on your system, and it should be run. Whether it is isolated, whether it has CPU control, whether it has memory limit, those things comes later, right? Now, the foundational part is getting the software itself. In the world of containers, that archive or that software is essentially a container image equivalent to your software package. Now, what does a container image contain? In a container image, it is not just your software or let's say you want Nginx. It is not just Nginx that is going to be there. It is going to have an environment which represents an operating system along with it, right? Now, if you have to run Nginx, let's say in Ubuntu, you need to have an Ubuntu, right? Now, what container is giving you is that it will give you an Ubuntu image on top of which you can install Nginx. Now that becomes a new image. That image you can download and run on any system. It doesn't matter whether you are running that image on another Ubuntu machine or another Red Hat machine or whatever, as long as containerization is supported on that base machine, whether it could be a VM, your laptop, or a server which is a hardware server with no virtualization, right? Whatever it is, if it supports containerization, this container image can be downloaded from somewhere and it can be run. And for the process, it looks like it's running inside an Ubuntu machine. That is what it gives in the simplest terms, right? Again, there are a lot of how it is happening and all, but that is what foundationally Docker gives you. Sorry, not Docker, the container gives you, right? So that is what container image is about. Now, how exactly the container image works? So again, we have to start from somewhere in the beginning, right? In a container image, right? Ultimately, what we are getting, we explained, you will have some package that you want to install. Then there will be another part of the image which represent the entire operating system. That is how it works. Okay. Now, when we start with a very simple image from the beginning, all you have is an empty plate kind of thing. Think of this image like a directory layout with some file system basics. That you can create directories, you can create files and all. And you let's say you took all of them and put it into a tar.gz. It's almost similar to that. Of course, there are nuances to it, but it's almost similar to that. That is what your image ultimately is. So when let's say as I mentioned earlier, right? If you are using an Ubuntu image and an Nginx together as an image, a container image, your image is an archive which contains a whole bunch of files that represent the Ubuntu system. At the end of the day, that Linux, Ubuntu as operating system is also a bunch of files in separate locations, right? It could be binaries, config files, everything in some layout, right? That is what you are getting even in the container image, right? You have all those base things, and then you have your software also on top of it, the Nginx software, right? So from the inside of the container, it looks like there is an operating system and a package installed on top of it, right? Now what we are doing is we will pull that image from somewhere, put it in the machine. What the container or container system does for you is get that image just like you did a apt install for your Nginx package, or yum install for your Nginx package. Container, let's say you just use Docker, right? It's a tool for managing containers. Let's say you are using Docker instead of that. The Docker does the same thing. It downloads your image from someplace over the internet or locally, takes it, puts it on the system, lays out the file system, and then kicks off. Then of course it will do all this magic of about creating namespaces, running C groups, and creating C groups, and assigning quotas, how much memory it can use and all those stuff. And then it will start this process that is intended to be started in the container. That is what, in simple terms, these tools like Docker does for you. Now, what exactly is Docker? There are two things, right? Now, what you see as Docker is one of them is the CLI, which is what you use for interacting with the containers themselves, that in a machine. Now, that is like a client. You could have a GUI. Docker has a Docker desktop client, or you could have CLI Docker, which most of you probably be using, right? These are clients for what? When you have mentioned client, there is a client and then there's a server, right? In the case of Docker, there is a daemon also that you install on your machine. It's called the Docker daemon. Now, what is the job of that daemon? We are creating a container, means container also has a standard called OCLI, Open Container Initiative. So it can handle lifecycle for any container. What is lifecycle? Stop it, start it, download it, update the container, create a new container, push it to somewhere else. All these things are part of managing a container, right? Different forms or different parts of the life of a container, right? So managing that container lifecycle is the job of a container runtime, right? So it's a container engine, right? Now container engine does that by talking to something in the system called container runtime. This container runtime implements the container, what do you say, that standard, based on which your client, let's say Docker client, Docker client talks to or forget Docker also, right? You have your container client. Your container client talks to your container engine. Container engine talks to the system, and then it creates and does all this magic about pull the image, build the run the image, build the image, whatnot, right? So that is how, and that's about why again the Docker engine or the container runtime, that is what it does. Okay. Now Docker is not the only tool in that arena, but let us start talking with Docker as the as a base, basically, because most of you will be familiar with that. But that is the fundamental idea. You have a specific set of you have an image which has the internal software that you want to run. Your container client can pull that image. Then once it gets on the system, your container engine can create a container. So it is like a process, right? What is the definition of a process in your system, right? It's a software that is the running state. The same thing applies to your container as well, right? You download a container image. It is just like your software. You have installed the software on the system. You haven't started it. Now, when you start it, that becomes a container, right? It's not an image anymore. It's a copy of that image which is in the running state. Just like if you had installed a Nginx on your machine without any container, you would have downloaded the Nginx package, you would have put it on the system, and then it starts up and runs the service, right? And when it runs, it is a copy of that process which is on the disk. It is the same way. Instead of a package, you have a container image. Instead of an Nginx process running on your base machine, you have a container running which has a process inside it. That is the whole difference between a regular software and a software running in a container. I will take a pause here. I know I put a lot of words here and a lot of things here. I would wait for a few more questions so that we can move, clarify them and move on.
Yeah, any questions from anyone? Otherwise, I think Safir, we can probably start with the demo and then probably people will ask questions. Yeah.
Sure. Yeah.
Excuse me, I do have a question before we start. Recently, I got asked a question. It is more like explain about container layers in a container and how we can optimize creation of layers. So can you explain on that? I have no idea.
Got it. So let us do one thing. Now we will start off with again I think we are a bit high on the time. So what I will do is I will start with the demo, right? And in the process, I will show you what images. Anyway, we have to cover that, right? So we will cover that. And I will show what what a layer is. Okay.
Okay, sure. Thank
That's good. Cool. All right. So everybody can see my screen. Right? It is visible. The fonts are okay, or do we need to increase the fonts or resize the window?
Currently, it's okay. Maybe when you launch, are you planning to launch, Safir?
Yeah, I'm going to launch now and start off with the whole thing. Okay.
Okay.
Let me start launching it. While I launch it, right? Okay, just a word about this environment, right? I am sure you can see that this is Red Hat, but this is nothing sponsored by Red Hat or anything, right? So it is that this is a lab that set up online by Red Hat and their associates. Basically, this is something like anybody can come and learn stuff, right? So all they are going to give you is a Red Hat machine for a short time. You don't have to sign up. You don't have to do any other magic. You just come to this link. You can have this machine for I don't know, is it 40 minutes, 50 minutes?
Yeah, 50 minutes. Yeah.
50 minutes, right? So once I launch it, you can see that there is an estimated time left. So in 1 minute, it will launch that environment, after which I will have 50 minutes to demo the whole thing, right? The same thing for you also, you don't have to worry about installing or messing up with your machine at this point. That is why we choose this environment. Of course, if you have a comparable Linux system on your machine with where you won't have any conflicts and issues in installing container packages, you can do that. But we are using this so that it's easy for everybody. Everybody follows the same instruction, and you don't run into problems that are local to your laptop or your server, right? That is the whole idea. So once
Safir, I just shared the URL in the chat. Should we have them also start now or later?
We can actually, what I would do, because given that time, right? Let's give it another, first 10, 15 minutes. I will just start with the basics, right?
Okay. Okay.
After that, they can also start. We will give some for 5 minutes. I can also take a break and grab some water or something. Right?
Yeah.
So I will start with that. I'm sure everybody got this, link that Shree shared, right? You can open it up, but you can read it later. It's quite simple, and they have made it in a very, very good way, right? So it will be quite simple to follow. So you don't have to worry about reading it now, right? So you can just follow the demo for the time being, but have this link handy and open up. Okay. Sorry guys, just give me a second. Close it. All right, guys, the environment is actually ready, and I can just start now. Right. So now, see, as I said, this is something that was given for by Red Hat for free to learn some of the things. This is an automated lab, not an automated lab. You have an environment, and on the sidebar you can see that there is a whole bunch of instructions, right? Now we don't have to follow this instruction. Forget this instruction, because this instruction is for a simpler lab, right? Now you can come back to this link and run this lab as well. But what we have is a bunch of different instructions, and that is why you are given that page, that Srijit is shared. It has the instructions here, what all things you should do. Even I'm going to just blindly follow this and then talk to you about what you are seeing, right? So that you will also do the same thing, and I will also do the same thing. We will be in sync, right? So that is why. So I'm going to start with these commands and explain some of the things we see, and we'll go along. And somewhere once I finish with a couple of basic stuff, then I will also ask you to start this environment, because as you saw, when you click on the environment, it takes 2 minutes to provision, and then only you can start. So don't do it now. You can take a pause, look at what I'm talking about. Then I myself will pause in between, and then you can start launching your environments. Okay. All right. What do we have here? So as I said, second, I'm just going to go here. I don't want to have these instructions because we are not following these instructions. Is this shell visible to you? I'm just going to type it. Hello. Can you guys see this command clearly, or the whatever output coming, or do I need to increase the font?
I can see it, but is there any way you can increase like control plus plus, control shift plus plus or something?
I'm just trying to do that. Let me see. 1 second. Control. No, for some reason it's not zooming in. Let me see. I don't know why the command line is not working. All right, so let me just use the menu for the time being. How about now? Is it any better?
Yeah, it's better now. Yeah. How about others? Is it okay? I can see echo, hello, and the output.
Yeah, guys, if you are not able to see, please call it out either in the chat
Yeah,
or
maybe you can
just
increase a
comment.
bit more, Safir, if you can.
Yeah, sure. Okay.
Okay, I think this is fine. How about others? Is it okay?
Yeah,
That's fine now.
perfect. Now it is good. Perfect.
Cool. All
Okay.
right. Okay. Yeah. Again, please, again, this is a live demo. In case you see anything not working or any problem, stop me, ask me, please. Okay. I think somebody is waiting in the room, waiting for to be admitted. Sweet. Okay. All right. I will just. Okay. All right. So I'm also going to the same link and going to just follow this thing, right? Now, as I said, right, they have provisioned the VM for us, right? This, there's a free VM basically that I have got. Now, what I'm going to show you is, I'm pretty sure you are all familiar with this command, right?
Yeah, so when you follow the document, anything in blue you can copy paste into the
Yeah.
terminal. Okay, just for your information.
I don't know if the browser issue, that control V's are not even working actually for some reason. Okay, I will just type it. That's okay.
So that you can inside right click and paste. That works with the mouse.
Yeah, that is one. So longer commands I will probably do that, but this one is easier.
Okay.
So again, this command might vary a little bit, between OSs, given this RHEL machine. So just showing what what runs under this this shell, right? What we are seeing as a shell, and this is a RHEL machine, obviously, right? You can see the information, right? So this is just a RHEL machine. And again, I'm sure this command also is familiar to you. Basically, you are looking at what is the kernel of this one, right? And you can see that the major version of the kernel is 5.1.4.0, right? So I just wanted to show that what we are dealing with, or where we are running this. Okay. So now if you go back, just like apt install and yum install, you have this one, right? So DNF is basically the command line utility for the package manager for Red Hat right now. So what we are going to do is install this thing. Okay. All right. So now we talked about Docker as a runtime, right? Let me see if I have Docker here. Oh, it is here. There's another command I'm trying. I will just have to explain a bit what these things were, right? As I said, Docker is what started off with the whole revolution of containerization, right? Even though the technologies existed before, right? And Docker has a Docker engine, which is the one that manages the life cycle of and your containers, start, stop, whatnot, right? And of course, this is Docker CLI, right? Now, for a very long time, we only had Docker as a tool for doing this. But now we have also another tool called Podman. Podman is a new entry, not as Docker had a huge community and a huge history for a long time, right? So Podman is a newer entrant. But what Podman or Docker gives you is basically the same thing. You can run containers, you can manage containers, right? The difference, however, is that between Docker and Podman, Docker's engine, right? It runs as a daemon on your machine. You have to have sudo access. No, of course, you can say that I'm sudo on this machine. I have a root permission, so it's not a problem. But typically, if you are running containers on your machine, using Docker, you have to have root privilege on the machine. Why? Because there's a container engine daemon that is running on the machine from Docker, and the command that you're running as Docker CLI commands, they are all going to talk to this daemon, and that daemon is the one who is actually doing the work. So for that daemon mode, Docker actually needs sudo privileges or the root privileges or administrative privilege on the machine, right? Now what Podman gives you is For Podman, the CLI and then engine is the Podman command itself. The Podman command itself will allow you to basically manage the entire runtime or the life cycle of the container without having to run a daemon. What is the advantage with that? First of all, you don't need a root privilege. The problem, one of the problems, few problems with Docker is that if you're running something, you are running, let's say, a container as a root. That means the process inside your container is also running as a root, and then it has root privileges, right? Now, when you are running a process as a root, there is always a chance of that getting exploited or that process getting excessive privileges on the machine, right? Now with Podman, that is not happening because there is no root. You don't need a root. Whatever process you want to run under Podman as a user, you can run that. So that is one of the fundamental differences. Again, this is not a session on Podman versus Docker. Just mentioning that so that now you are clear. I might be mixing and matching these commands basically. Docker and Podman has the same options. Again, Podman came later, so they just said that we will be compatible with all the commands that Docker provides with you. So every command that I run here, you can run it either using Podman or using Docker. Okay. So I'm just going ahead with the rest of the session. Okay. So what is the next command? There are two commands here. I'll just go to one begin with. Okay. So one thing, right? I talked a lot about what image is, right? Image is like a package, and you have entire what do you say package, the operating system, running as your 1 second that is running now. All right. So the idea was that you have entire base of an operating system plus your packaged as a container image. That was the idea. Now, what I'm going to do is look at images. So when you have this is a fresh system, right? And I have just installed container tools. Let us see if do we have an image that is available to us locally. So just like you download a software package and install later on the machine, you can also download an image, keep it on your machine, and then run the container later on it, right? So I'm just going to see with Podman command what is the locally available package, container images here, right? As you can see, there is no container images in this machine. Now what we are going to do? Sorry, share that. Give me a second, guys. My browser froze. All right, so I'm back here. So again, we talked about just going back to the example of installing an Nginx package for Ubuntu or well, right? Where does that package originally come from? There are remote repositories of softwares from where your package manager pulls it down, downloads it, and then installs it. Just like that, for container images, there are going to be container registries where people can push these images, upload these images, and later somebody else can download it and use it. Okay, so there are the default container registry for anybody in the world nowadays is docker.io because Docker Hub, or as we call it, it's Docker Hub. It is provided by Docker. It's a free service, right? Even though there are some conditions about how much images you can use and all, but that is one of the registries. But nowadays there are large number of registries. GitHub provides with registries, Red Hat provides with registries, Google has its own registries, and you can have your own private registries if you are running stuff in the company. You can have a registry for your own applications which is not in the public, right? So your registries can be public, private, authenticated, unauthenticated, secured, unsecured, everything. But at the end of the day, it's a repo somewhere out there on the network from where you can download a container image. Okay. Now what I'm going to do is from the default registry, which I believe is Docker Hub, I'm going to download an Ubuntu image, which is provided by the Ubuntu company themselves. So let's just try to do this. Just keep an eye on the the output, right? So what it is trying to do is trying to pull docker.io/library/ubuntu:latest. Now what it says is, look, this is your registry. I know about this registry because there is some configuration where this information is provided. So what I'm going to do is I'm just going to look at the default Docker registry and then download this Ubuntu container image from a location, right? Now, if you downloaded it, it is doing a whole bunch of copying the data, copying config, writing. It gives you a lot, whole bunch of output, right? But at the end of the day, let us see what is actually happening. Look here. Earlier, we didn't have any images here. Now we have an image. What is it saying? The repository where it came from is this. Tag is like, you could have different tags for an image. To say like, you have view, Docker 22.04, 23.10, whatever, right? So those will be indicated as tags. And right now it is latest. Latest means like, whatever is the latest, Ubuntu version that, Ubuntu has provided, it will pull that image. Again, this is about versioning of any image ultimately. Okay, that is what tags are used for. Image ID. This is a random hash or a random number, string, which is created, local to your machine. This has no global significance. It is just downloading this image, and what it gives you is you can do anything with this image using this ID or this name either, right? And of course, the last item is important. It has a size of 8 MB, right? Now, if you are installing an Ubuntu in itself on your machine, if I remember that I installed one recently, it is 2. If it is a server, it is 2 GB something. If it is a desktop operating system, it is 4 GB. But right now, what you're seeing is an 80 MB image. So there is not enough stuff there. Why? We will see why that is the case, in a short time. Okay. So we got the image, right? Let's see, what is next. Again, they are also talking about pulling another image called UBI8. Okay, let's pull that up. Just like the same thing, right? Images. I pulled the Ubuntu earlier. Now I'm going to pull UBI8. Okay. We will not look at the output again. Like the output, of course, you can look at the output, but it's the same thing, right? It is just downloading something. Let's just go back and see the images. So you have 2 images. You can see that See, the first image of Ubuntu came from Docker Hub, which is the URL is docker.io or the domain. Now UBI8 came from Red Hat. They have a registry from where you got this image, right? And it is 213 MB actually. So you can see the difference, right? There are different sized images. Every image will be different depending on what all softwares are inside that system, and that is why you will see different sizes like this here. Okay. Let us move on. I think I'm sure you would have got some idea about the images. I know somebody asked the layers question, and we are still to get to that. We will get to that later. Okay, but let us start. Kick off the basic. Okay. Now, even in this page, you can actually see what is the output and what you can see and all. Okay. Now, what I'm going to do is from this image, I'm going to create a container. As I said, image is just your package or an archive that is downloaded and sitting on your disk. Now, if you want to run a process out of it, you need to run that. That is when it becomes a container, right? An image, a container image in a running state is your container. So that is what we are going to do. We are going to create a container next. Okay. I will explain the command line options, of course. Just let's just kick off that first. That was very cute, right? Now you are in a different shell, right? Now you were here earlier, and now you are in something else. So what are these, command line options? Podman, of course, Podman, or you even if you use Docker run here instead of Podman run, it will work, right? They are compatible. Now ignoring that part, it says run. Obviously, you want to run a container. From what? From an image. Why we are just using Ubuntu? Because that is the name we used here. So the system knows that if I say Ubuntu as an image, it is going here. Now what is this Ubuntu? It is just a name that we provide for the container that we are running. It is not the image's name, it is the container's name. I can very well name it, hyphen names are here. No problems, right? It's just a name. And even if you don't name it, Docker or the Podman will automatically generate a name for you and assign it. Okay. Why do they do that? So a container wants to start running it. It can also have an ID, just like you can see the image, image ID. There will be a similar type of hash or string ID assigned to it. Or you could use the name also, to manage the container, right? That is why, it is given a name. And what is this thing, right? So now we have a container of Ubuntu operating system, and what we are telling Podman or Docker is that our container engine is that look, I want this image, but within that image, run this command for me. Because at the end of the day, a container runs with a process. You can't start a container or have a container without a running process, because the whole system of namespace, everything else, right? It's also all about running just one process in an isolation, right? Now what we are saying is, okay, fine, you have an isolation where it looks like an Ubuntu image or Ubuntu operating system, and run the bash command over there. That is why when I ran this, I got into the shell, because if you run bash as a command, you will get a shell, right? If I run a web server, I will get a web server, all right? Now here I'm getting a shell. So what we are going to do is just to see here, right? I don't know if voice release exists here. Yeah, it does. What do you see here? We were on a Red Hat machine, right? Where is that thing? Sorry, 1 second. You see here, the first command we ran was for just to find out what is the OS on which we are running, which is Red Hat Enterprise Linux, right? We saw all these details. We saw the kernel version as well, that 5.14.0, right? Now where are we? We are inside the container, which has a different operating system. It is not run anymore, right? We just came from run, ended into a container of Ubuntu, right? And this is what we are seeing. Let's see, what is the kernel here, right? Notice anything different? It is the same kernel. So this is how, if you saw that, and I told you about the size of the Ubuntu image, right? It was just 80 MB or something. And a regular OS image of Ubuntu would be 2 GB or 4 GB, depending on what image you download, right? Now, why is it only this much? Because an image is just a lightweight drilled down version of the OS. It just has the minimal file system layouts and other things that is for the directories and files required for running that OS as an Ubuntu OS. But what is the core of any Linux system? It is the kernel, right? Now, what happens with containers is the kernel that any container will use is not its own container. Sorry, its own kernel. It uses the kernel of the underlying operating system, which in this case, we have a RHEL machine, which has a version of 5.14.0 kernel. And every container running on this machine, whether it is Ubuntu, Fedora, or whatnot, they are all going to use the same kernel. It is just that within the container, they will have the directory layout and files resembling or representing an Ubuntu image. That's all. But no kernel-wise files basically. Okay, so that is the idea. Now we went for Ubuntu. Let us try to do the same thing for UBI as well, right? Again, if you follow through here, you will see that this is the same case, right? Now we are just going to run this one as well. I'm going to name. Sorry guys. So what happens is, this is Linux system, and on my work machine it's a Mac. So I keep switching between command and control, and it messes up the terminal browser sometimes. Sorry about that. So what I'm going to do is I'm going to name this RHEL, because it's at the end of the UBI.8 image we downloaded is actually a Red Hat image. So I can name again. I can name it anything. I'm just going to name it. Right. Similarly, we got the same thing. All right. Now it's 8.9, right? Now what is it? We have same version, right? 5.140. So that is the whole point. The kernel is coming from the underlying host what we call host operating system. What you are seeing in the container is a guest basically, right? Of the container OS basically. So container OS can be different. Host OS can be different. You can run n number of different container OSs inside the a different host OS, but everybody is going to use the same kernel. That is the underlying message here. Okay. All right. So I exited from both of them just to show you quickly what happened with our containers that we ran, and I just exited from that, right? Yes. So this is a command for seeing all the containers running on your machine. It could be Docker ps-fni as well. Actually, let me, rather than saying that, let me just say Docker ps-a. Okay. So what you can see here, there is a container, as I said, it has its own IDs, right? Just like image IDs. And it says, what is the image this container used, and what is the command it ran, And when it was done, what happened to the container now? Why it is saying exited? Because we launched the container just using bash as a shell. And the moment I exited out of that using control B or exit command, that process doesn't exist anymore. The moment that process exits, the container doesn't exist because the container is wrapped around a process basically. So you have to have a process. If you want to create a container out of a container image, there should be a process. And our process just exited, or I exited the process, and obviously then the container went away. Okay. Now the container, the thing with this is why if it exited, why it is still here? I can actually start this. I can start the container again using instead of run, I can use podman start or Docker start, and I can start this container. Okay, that is why it is still there. Or I can just remove them as well. There is a podman add, and then you can remove it. All right, so here mostly.
So can we have everyone start the lab right now?
Yeah. I was trying to see where I have to checkpoint. Yeah, it looks like because we covered the base, right? Let us start the containers now, and do one thing. Go here, start that the beginning of the link. You have that where to launch this lab. Start that. Then you have 2 minutes. So meanwhile, you can also ask questions or post questions in the channel. Okay.
Yeah, so I posted the link again in the chat. So everyone please click that. So that is our workshop documentation. Please click that. And when you click that, you will get to the same document which Safir is sharing in the screen. Like Safir said, you need to instantiate the workshop environment. It will take 2 to 3 minutes to instantiate because it is running in one of the public clouds. Please do that as a first step. And then we are actually going to do the hands-on activity for the next close to 40 to 45 minutes. Like I said earlier, everything in the document which is written in bar is basically a command which you can copy paste into the terminal. Okay. Is that clear for everyone? Any questions? I have started the environment like mentioned in the document. In fact, please give a visual clue in the chat when my document comes up. It's important that when you start the environment right now, because it takes 2 to 3 minutes to instantiate it. So if you have facing issues, please let us know. Otherwise, if it's going fine, please give us some message in the chat so that we are more on the track. Yeah, one of you who are following that document and started the environment, please let us know in the chat. Or unmute yourself in the mic and tell us. That will help us make sure that we are following this. Am I audible right there, Sapir?
Yeah. Hey, sorry guys, I just stepped out. I forgot to mention that and stepped out. Sorry about that.
But am I audible?
Uh-huh.
Am I audible?
Yeah, there is a breakage. I don't know if it's my network or your network.
Yeah, maybe it's my network. So I was basically suggesting everyone to follow the background.
You are breaking up a little bit. Second. Okay, what were you saying, Shahid? Either you can say again, or you can just put a message in the chat.
I was just thinking about click the data for the chat.
I still can't hear you. Okay. Okay. So just asking everybody is, does everybody has the environment, or is there any questions?
Sir, am I audible?
Yeah, you're audible, but that is the voice is kind of breaking. Do you
Oh,
want to just try reconnecting once? So folks, you can run up to the commands that we have mentioned, like that would be, let me just see. So you can stop by the time which is security in containers and images, right? Then we will take it from there. Until then, like you can start running them. Yeah, of course, like you can also keep asking questions in the side. If you for some reason your sound is not working or anything, just put it in the chat. We will keep replying. Is that you? Can't hear.
Yes, so you can provide something for the account.
What's that? It was that you? Sorry, couldn't again. All right, folks. I'm assuming all of you are following the document. If you are running into an issue, please unmute and ask the question. Or if you think that either your voice is not working or my voice is not working, please put it in the chat. That definitely works. You can ask the question there. But if you are able to do it, please follow all the of course you already saw it. So if everything is working for you, please give it another 3-4 minutes, and then we will move on to the next part of the workshop. Okay. So you go follow up to this instruction here, like in security in containers and images. Then you 3:38, we will start the next part of the session at sorry, 8:38. We will start at 8:41.
Yeah, I just tried using my laptop mic directly. Can you hear me?
Yeah, much better. It's crisp and clear at this point.
Okay, so I'm not using headphones anymore. So thanks Humble, thanks Safira. So I was basically saying to follow the document.
Okay, yeah.
Basically now we can do in parallel, like Safir is doing. You can also join Safir and do it so that it becomes more interactive.
Correct, yeah.
Yeah. So has anyone reached the point where you pulled the Ubuntu and rel-based UBI 8 container image and did those steps?
Yeah, yeah.
Yeah, I just tried using my laptop mic directly. Can you hear me? Yeah, I just tried using my laptop mic directly. So thanks Humble, thanks Safira. So I was basically saying to follow the document. Basically now we can do in parallel, like Safir is doing. You can also join Safir and do it so that it becomes more interactive.
Correct, yeah.
So I see Ajit saying working for me. So Ajit, we are seeing you are already inside the environment and doing the commands, right? Yeah, okay, perfect.
Cool.
Others also, please, if you face any issues, let us know. We are here to help. Okay. Um,
So see, I was telling them, I don't know if you heard, like, that, we will start the rest of the part at, 41, which is like 2 minutes away.
right, right.
Time to, yeah.
Yeah.
So after that, we will start off. All right, again, anybody has questions, problems, please post in the chat as well. Right?
Yeah, yeah,
I
please.
started, at the, 8:41 I start. Even after that, in case you feel like, you don't want to interrupt or anything, please put in
Right.
the chat. We are all looking at the chat. We will follow and, respond to you. Okay. Ask any question. As I said in the beginning, right? There is no wrong questions here. Please keep asking.
Exactly. Yes.
Yeah. Even if I spent it once and you missed it totally, okay, please ask.
Yeah, so Husni, I see your command podman run dash dash name rel. This command is not working. Make sure that you type it in the same line. Okay. Maybe Safir, if you can show that same command in your terminal.
Yeah. So what is the error you are getting? Can you paste that as well here, Husni?
Yeah, Husni, if you can tell us the error, that probably would help us. But otherwise, Safir is going to type the same command, which he already did a couple of minutes back. Yeah, if you look here.
I believe this is the same command, right? If you see word by word, there is no difference, but there could be problems. So can you just tell us, like, what exactly is not working? Like, what is the error you are getting? There should be some sort of an error, right? Please paste that error as well.
Yeah. Yeah, so Ajib is correct. If you type the same command twice, you're right, because the container might be already there in the same name. But if you're doing it for the first time, it should work.
Yeah, again, Hussein, if you can, again, like, just, adding on, like, what Ajib and, like, Srijit said, right? This is what is going to happen. I'm just going to run the command again. See? What am I getting? Creating the container storage. The container name rel is already in use, right? So am I getting it? Remember the command? I'm just looking at running containers, and their names are all this. This is like, just like, your sign up name, right? So the name is already taken. Well, let us say I change it to, like, there are two ways to do this. I'm just going to say, like, the name is rel2. It runs perfectly. Okay. Now, let us say if I run this command again with rel2, it is going to give me the error. Why? I have the, rel2 name taken already, right? I can't. Now, if you don't want this existing, see, there are two ways, right? One is here, now you can start this container. Yeah, the copy pasting here is okay. Right? What happened now? See, this was what happened here. It exited earlier, look at rel2, right? The bottom line. What happened? I started it using the ID of that image, basically, right? I did a Docker start or Podman start, right? I do that. It started. Now, if you see here, you can see that, like, the container is in the, up status again, right? Same container. The ID is the same. I started it, right? It is running now. I can also stop it now. See? Exited 3 seconds ago because I stopped it. Now let's say I want to, run the rel command again, like, you, so that now I cannot run, wait a second, I cannot run this command again. Why? Because that name is already taken, rel2 is already taken. So I can do For a change, I'll just use Podman. This name is the thing. Yeah, this copying always has a problem with it. So I don't know. I just did Podman Aram of that ID. You don't see rel2 anymore. Now I can happily run this command. Which one? This one. See, I got the container again. Now I'm going to say I exited from it, which means the container is exited, but it remains in the system. You see here, there is a container again with rel2 as the name. But what you have to see is on the left side of the container ID, the number is different, right? Earlier, what you had was like something that starts in E97. Now we have 48. It's a different ID, right? So the container is different. It's just that like, I gave it an additional name, which is human readable and it's easier for me to use. That's all. Okay, I think we are 45. So we are 4 minutes past, but I'm hoping that clarified some of these things. All right. So let us move on to the next part of the image, right? Okay. So far, what did we do? We actually pulled an image that somebody else created and just ran it, right? That's what we did. Now, what are we going to do? We are going to build a container. Why do we need to build a container? Essentially, our final purpose, as I said in the beginning, right? We want to run an application. We want to run a command. That's all our purpose is, right? So that's exactly what we are going to do. Yeah. Okay. So what is our instruction here? We want to clone this thing. Basically, this is a GitHub link. We are going to clone some code from GitHub. Essentially, that is what we do when you develop an application, right? I'm getting that code, building the code, and deploying it in container. That is what we're going to do here. Okay, so I have it checked out. I have this repo checked out. I'm just going to look here. Let's see what we have here. Okay, it's quite simple. You have in the root, you have readme license, the typical stuff, and then you have folder, right? I'm just going into the folder. Let's see what is there. Okay, this is also quite simple. I have a Docker file, then I have something called Docker file, I have a multi-stage build, then have something called main.go. Right, we will get to Docker files in a moment. The third file, main.go, is essentially a Golang file, which is your code basically. Okay, so that code has to be compiled and built, and then we have to deploy. That is the entire idea, right? So to do that, let us first look at this file. Now, to deploy this, what do we need? We need a new container with this code, right? So that means that, with this code, after building the binary, I need to deploy it as a container, which means I have to build a container at the end of the day. That is the idea. So if I have to do that, then I need to have a Docker, something called a Docker file to build a container. Why? Docker file gives you a series of a set of instructions. Okay. Now those instructions, essentially what it does is, it tells you what to do and what is the end result of a build of a container. Okay. Now I will just explain this file to give you a better idea. Look at the first line of the file. It says from. The first part is always a Docker command or a Docker file command, right? And then the rest of things on the line is basically arguments to that command. That is how the Docker file works. And a Docker file is a series of one or more commands basically. Okay. Now, first line is saying from docker.io/library/golang, which obviously by this time we know that this is a repo image URL, right? It is a registry of images from where we are downloading a particular image called Golang. That is what we are saying from. From this image means download this image for me, then move on to the next steps. So we are downloading the image from there. That is the first step. What is the next one? Copy. Copy essentially means copy only. What it says is dot. Dot means the current directory where we are standing, which is the workshop directory, right? whatever is in here in the current directory, copy them to the downloaded container. Container, of course, is like, it's like an archive or a file system in a location, right? Now, copy these files into that location. Then what to do? We are just at this step, we are just copying. Let's say, what do we have? We have a Docker file, multi-stage build, and then we have main.co. These are the things that are in this current directory. So what Docker is going to do is take these three files from the current directory, which is indicated by the dot, and put them into a directory called /KCD Kerala, which is going to be created inside the container that we downloaded from the from location. That is what it is going to do. Okay. Now, what it's saying is work dir KCD Kerala, which means switch to that directory. It's just like CD into that directory. Okay. Now, what happened? The Docker downloaded some image, copied this contents from this particular workshop one directory into /KCD Kerala in the image. Then it switched to that KCD Kerala directory. Now it is saying run. Run essentially means any command, just like running something in the shell. It will blindly just run that command. That is the idea. Now, what is it going to run? Go, which is the go command, build and main.go. This is exactly how you build a Go program. Whether you're on a machine, container, or whatnot. At the end of the day, you have a main.go which you are going to compile and create into an binary, right? So what we are telling Docker is just compile this for me. Okay, and the last is a little bit intriguing thing. It says entry point, right? And the location what it is pointing to is /KCD Kerala /main, right? We will get into that in a little bit, but let us start building it first. Okay. Why we have that entry point is something that we will use it in a moment, but let's do this. So again, these parts I did already. I went to the directory and then I explained stuff. Now we are going to actually do this. Okay. Okay. So what is the command here? Docker. Again, Podman suffices. Podman build also works. Docker build -t go app. We are -t is a tag actually, but what you are saying is my new image that I'm going to build is going to be named Go app. Okay. Now I'm going to build it from what do I build? Take the instructions from the Docker file that I'm pointing to using -f argument. So Docker is going to look into this Docker file we just saw, then create an image out of it, and then name it Go app. That's what it's going to do. So let us just run that.
Has anyone reached this step as part of the document? Any one of you are doing this parallelly in your environment?
Yeah, I'm doing parallel.
Okay.
Folks, if you have not reached this stage, please call out. All right. You guys can hear me, right? Can you confirm you can hear me? It looks like my video is frozen. Srijit?
Yeah, I just had to move for 10 seconds here. What did you ask me, Safir?
No, so my video seems to be frozen. I don't know if you can see me moving or anything. I thought my network had an issue.
No.
No, sir, you're audible.
You're audible.
Okay.
Yeah.
And how about the video? Because I can see the video that I'm just frozen in the video. I don't know.
Looks good to me.
Yeah.
Can you
Okay,
type some
good. As
command
long
or
as you guys
something?
are able to hear, that is good enough.
Yeah.
My face is not important. Just worried that my network was gone. All right, guys, let's get back here. So let us just quickly examine what is this output showing here, right? Okay. So what we will do is we started from here, right? Docker build. That's our command. We saw the file already. We went through all the file. The only thing I didn't explain is the entry point, which we will get to later. But this is the command I ran, right? Now what you're seeing is steps, right? If you see, our file has like 5 lines. Each of them is a step. So the first step they are executing from Docker, right? Now what was the meaning of this one? Download the image first, because we haven't downloaded this image before. So we are downloading it, freshly, right? So it takes a bit of time. It downloaded it, and then it moved on to the step 2 of 5, right? 2 bar 5, which is copy dot to slash KCD Kerala. It was done. Then it went to workdir slash KCD Kerala. That is the next step. And then it ran the build, and then it set the entry point, and it did a commit go up. If you see the last but one line right here, commit go up, which means you see I did all the instruction that you have done given me, and now I'm just committing this image. Okay, it's done. And what is saying successfully tagged. Remember, tagging is the way to give it a name, and if you have an optional version or something. We didn't give any version or anything, so it is saying that by default it's going to be go up latest, which is totally fine for us. We will just refer to this image as go app. Okay, so we are done here. I said we have built the image. What it said is in the last but one line, successfully tag localhost slash go up, which means see we didn't push this image into anywhere, right? This is locally built right now, just like you compile something on your local machine. It built an image, but it is locally available. So let us just go here and see what happened. You see here, these are all things that we downloaded. UBI 8 and Ubuntu we already downloaded. You are seeing a Golang here because in the Docker file, when Docker was building the Docker file from the Docker file, it downloaded this image, so it is available locally here now. And then this is the image we built and locally available. That is why in the repository name you have a local host. This is locally only available. Okay. Clear so far? Okay, I will move on. So basically, I think there was a question about layers. I will do a quick attempt of answering what a layer is, right? Or should I finish? Can somebody confirm you guys have followed up to this point in in this one workshop?
Yeah, all of you are following. Have you reached this step which Safir was demoing, building the Go app? Can anyone of you confirm whether you are in the same step or ahead or behind? Okay, Amritlal is there. Thanks, Amritlal.
Shall I assume that anybody who didn't respond is also it's already there? We are asking because if you are stuck somewhere, if you want some explanation or help, we wanted to provide that before we move on to the next session. If it is not in the interest of time, we can just we will just move on. Is that okay? Again, please put if there's an issue in the put it in the chat. We will follow through, but I will move on to the next part of the workshop. Okay. All right. So again, this command is quite familiar to you at this point. I don't have to explain, but we are going to run. Oh shit. Okay. I think you took a lot of time and it took this time. See, this is the one problem with the session. So I will just start it in a moment. Okay.
Okay. Yeah.
Yeah. That's okay. So what I will do in the interest of time, right? Somebody had a question about layers. I actually wanted to store that in the shell. But in the meantime, what I will do now, you can see my other browser that I'm opening up now, right?
Yeah.
I'm just going to quickly explain what it is, right? All right. So think about the image, right? We just built an image from another image, right? That is what we did. Now that is all totally fine. But where did we start with, right? when somebody has to build an image, who built the first image? It's just like that chicken egg problem, right? What was the first image that we built, right? Now, to know that, I don't think I have. Okay, I will just explain it. And so let's say, for every image, right, there is a very base image which is kind of like an empty template, which is called a scratch image. Every image starts building from that, and then what happens is everybody who builds a base OS image, OS-based image, let's say Ubuntu or RHEL, they take this base scratch image and then goes through a specific build process through which they will build the next, their OS image. Now, on the top of that OS image, you could add one software, let's say, right? Let's say, you got an Ubuntu image that we, downloaded in the beginning. After some time, you install Nginx on it. Now that's a fresh image, right? You took Ubuntu, you create, added Nginx to it, and then you built that as a new image. Now you have a new image which is inherited from its parent is basically that Ubuntu image, right? Now you install Nginx. Now you are feeling that you also want Tomcat on that one because you are running a Java application, right? In the next step, you took that container and then which container? Not the Nginx container, the container that you built by adding Nginx to it. You took that and then you built another container which contains Tomcat as well, right? Now, when you do that, you have a new image. So, which has the parent, which was your earlier image, right? That is why I wanted to start with this one. Let's say in the beginning you had, let's say, something called crash. And let's say after that you had the scratch there, and that was a container. Then somebody built an Ubuntu container on top of it. Okay. Now, what happens is when this Ubuntu container is built, it essentially adds a bunch of files to the existing base, container. Okay. So I will just say, this is the Ubuntu image, this is actually scratch plus a bunch of Ubuntu specific, file. Okay. That is how this image is built. Whatever is there already in this scratch, we added this. Let's say now you want to add Nginx here. What you are getting is you got an Ubuntu image which was built in the previous this stage. Then you added Nginx and maybe a whole bunch of you added your own custom Nginx configurations or put some files. Maybe you just put your name in a text. I don't know, you did something, right? Now I'm just saying that you added Nginx plus bunch of files, right? That you put on top of Ubuntu and built a new image. Now I'm going to call that image Nginx. Okay. Now this image, let's say I later put just like this. I put I put Tomcat here, right? Now what I'm doing in this process is essentially this is your one image. Then I'm making it a new image, right? Which builds an entirely new image. From that image, then I'm adding something to it. Then I'm building a new image, so on and so forth, right? Now this results in a Tomcat based image actually, right? Right. This is the you have Tomcat image which contains all these things. It's an inheritance, right? Now if you just see here, what happened is this is a layer, bunch of layers basically. Now we added something to scratch here, which made Ubuntu. You added Nginx and a bunch of files here, which made Nginx container. You added Tomcat later to that, and you built a container which resulted in Tomcat container, right? Now, if you want to run Tomcat, you are going to just download this container in your Docker build file, or you just do docker run docker.io / Tomcat, which would give you Tomcat container, right? Now we did this and we have this image. Now each of these things that we had inherited or is the parent of this image, right? Layers. When you inspect or dig into this image, what you would is find there is a new layer here, but there are a whole bunch of layers where Nginx files were there, Ubuntu files were there, Scratch files were there, like that. Okay. And what does this mean when you say layer, right? Think of it just like any you have a bunch of sheets and you put one on top of other, right? It is just like that. The difference is that here this layer stacking basically worked on inheritance. let us say you had a file called /etc/KCD Kerala in Scratch. When you build Ubuntu, unless Ubuntu has a save file, this file will be available in the Scratch layer. Ubuntu won't do anything to it. But we will see this file, but originally that file is coming from Scratch. Now let us say in Nginx file, you modified that and created a new file, right? If that happened, what would happen is your file, that file will be overwritten, and you will see a new file. That is what is going to happen. Okay. So that is what fundamentally the layers are all about, and we can also see that in the actual workshop. But again, this is the basic idea. Think of it like every layer is like the previous image that came before it, from which the origin, the image that you are seeing now. If you ask somebody ask what is the layers for this image, it is just this, right? Like whatever images from which I built and inherited this image, those are called the layers. Now how the layers works is based on, as I said, like on inheritance. If you dig into that, there's a lot more to say, but like that is the foundation of it. There is a whole bunch of layers, and like those layers constitute an image. Okay, so we'll just come here. I'm just quickly going to this example of, again, I don't have to explain, you guys already know that this one, right? So I'm just going to quickly run through this.
Yes, Safir, you may need to install Podman.
Oh yeah, shit. Okay,
Yeah.
that's the problem, right? Okay, like that.
em-y install, yeah, container dash tools.
All right. I have the container tools right now.
And Docker files are inside that workshop 1 directory. Perfect, yeah.
Docker files. I believe this is the command that we used, right? So I'm just
Yep.
going to build it again. Yeah, remember that all my earlier images and everything is gone because this is a fresh installation, right? But again, let me just show that. I'll just avoid that. There's my images here. Okay. I'm just going to run this and build it. Okay, this is all something that we have seen. It's actually downloading the is step 1/5. It is just downloading the Golang image from docker.io. So again, what is a Golang image here, right? It probably is using an OS, some sort of an OS image, and all the Golang tools which is required for compiling a Go program is added to that, and somebody built that and put it in docker.io registry. That is what happened. And now we are pulling that because we know that that container has all these build tools, right? Okay, now it went to the step 2. These 2 steps are quite faster because there is nothing much to do there. Step 4 will take a bit of time because it's building a program. Okay. Okay, we are good again. Okay. All right. Docker images, right? So what are we seeing here? This image obviously can be downloaded in the step 1 of the Docker file building. And then when we built it, we have a local host slash Go app also, right? Now I'm just going to quickly go here and just run this Go app. Okay. You see here. This is where we were broken when my container or my environment died. So we are going to restart from there. Okay, what happened now? Earlier we got a shell, now we are not getting a shell. Why? If you see here, we have the container here, we ran the container and it's successful. Why? It is saying that Kubernetes community days Kerala, right? Which means we did something good, the thing worked basically, right? It's a successful message basically. So let us just go back to the Docker file, right? See, earlier, if you remember, I put, if I ran Ubuntu command, so Ubuntu image, then I said, as the last argument /bin/bash, so that bin-bash command would run inside that Ubuntu, container, right? Now, I didn't do that here. I just ran what was the command I ran? I just ran it with a name and just the, container name, right? Container, so the image name, right? That is what this last, entry of entry point comes into picture. What does entry point do? Entry point actually defines that look, this is the default thing that you have to run if somebody is running the command, container as it is without providing an argument. This is the entry point. Think of it container is ultimately have to run a process, right? And this is the gateway to that process. That is what it is essentially saying. If you want to enter into this container and do what it is supposed to do, which is to run the program that we just compiled, the Go program that we compiled, then entry point is KCD Kerala /main. Why main? When we do a default compilation of a Go program using Go build, it provides creates a binary called main inside that directory. That is why you are seeing that entry point with main. And what does main as an executable do? It just throws that message of Kubernetes community days Kerala and exits. And that is why exactly why you saw that when we ran this command, right? So how did we so again we are obviously seeing that there's an entry point here. Okay. Now instead of so there are two ways for to run something inside a container. One is an instruction called CMD. The other is called an entry point. Okay. Here we are using entry point. Entry point cannot be modified. CMD is something that you can pass as an argument to your container from outside. Okay. So what I'm going to do is again if you have a question you can ask later about the entry point. I will just show this also so that now you get that idea. Okay. I believe. Okay. I'm assuming my command. This you may not see in the your workshop actually. I'm going to say let me see if this works. Sorry. Okay, it's already in use. Obviously, I also forgot to give it a different name. In the interest of time, I'll just give it a different name rather than leave it in the container. See, I just went into there. What happened now? I overread whatever that entry point was defined in the actual Docker file and the container. I told Docker explicitly that use a different entry point, which essentially says take this container but run this command instead. Okay. So there are some subtle differences between CMD and entry point in Docker. I would leave that as a as an exercise for you to try out later. You can just search for Docker or container Docker file CMD versus entry point, and you would get the full answer. It's quite straightforward, but it's good to understand this difference actually. Okay. Oh, see, where are we now? We are inside that Golang image that we pulled down then we built that Go program, right? If you remember, right, the one of the instructions, what was the second instruction, copy dot KCD Kerala, right? So what it would do was from that original workshop one directory, which had a Docker file, then there was another Docker file, and then there was a main.go. It will copy all those contents to this directory inside the container. That is what it was going to do. Obviously, as you can see, all those files are here inside the container, right? Now we saw that this is the file, right? So it was able to copy, but we are seeing an extra file made. Why? In this instruction, so what did we do? We copied all the files to this KCD Kerala. Then in workdir KCD Kerala, we switched to this directory. And then we ran this build, which resulted in this binary file. Right? This is a binary file. Let me just run it directly, right? I'm assuming all of you know how to run a Linux process, right? So see, what does it give me? The same message that we got earlier when we ran the container, right? So this main program just does this much, right? Earlier we ran it as a container. Now we just got into the container and running it manually, right? That is the only difference here. I'm hoping that that was clear to you all. Now I will just show you one more thing. We did this for all the images that we did, right? I am curious to know, we just pulled a Golang image. What is actually it? As you can see, this is a Debian 12 image, right? So somebody took a Debian 12 image, put all the Go programs here, which is required for compiling a Go software, and then created a image in Docker Hub. That is what we did, and that is what we used in our Docker container. Okay. So just exiting from this, I'm assuming this is clear to everybody. Just for okay, so this is fine. Let us go back to the one thing you have to see here, right? So okay, we are here already. Any questions so far? I would just like to get a checkpoint and ask if you have any questions. Because we will near our workshop end in like another 10-15 minutes. So if you want to ask some questions now or even at the end, it is fine. But I'll just stop a moment for asking the question.
So we'll have only the Linux-based images. Can we use other operating system as well?
I don't think there is any other images for Windows or macOS. I don't think there is an image for like see, you can run Docker on Windows or Mac with some workarounds, but at the end of the day, this is a Linux thing, right? So the images are going to be like Linux images only.
Okay.
All right. Let's just look back at the images that we have, right? To see here, I told you like the last part of again, see, we built a image, this is something we can deploy so that we can deploy a software like this, right? Now just like look at the performance or like what it exactly is taking up, right? You see here, this image which you downloaded directly from Golang, which we didn't modify or anything, like this is the pure Golang, that image that we downloaded from Docker, it is 838 MB, right? Now we added that simple like small Go program to it, which I believe, I don't know how much is the size of that, the whole thing. You see here, right? This directory is only 12K, including those 3 files, right? Now, what happened? After we did that, it resulted in an increase of, I don't know, roughly 30 MBs, right? This is the image we built, right? Now from this size, it went to 30 MB extra. 30 MB is not a big deal, but you can see that like, with just this file, it actually, the size actually went up to this much, right? Now, why are we discussing size of the image itself, right? There's a small problem. Let's say, when you are running just one container on your machine, this is not much of a big deal, right? For us also in this workshop, this is not a big deal. But what actually happens is, let's say you are running this in a Kubernetes environment where like, you are taking containers and like, putting it in a production environment, right? The bigger your image size is, it takes up like, more space in like, your memory, your startup increases, all those kind of things can happen, right? Now, that is fine if that is what it takes to run your program, right? But if you saw what we did earlier, right? It is just a binary. To run a binary, why do we need this kind of bigger file, like image, right? We also saw that that Ubuntu image that we downloaded was only 80 MB, right? Now, while I can run this localhost/go directly and like run this image in the production, why do I need to have that much disk size, right? Why does it have this much disk size? Let us just look at this image, right? What we saw was like Debian 12 is what like the base of this image is. I'm just going to do 494 Debian, right? I'm just trying to see like how much the default Debian image size is. See, that Debian is actually 121 MB. This is actually the base for your Golang image. It could be a different version. I'm not 100% sure, right? But this is the latest Debian image. And Debian 12 is actually the latest Debian, right? So it might be a minor version difference, but this is the, one of the images. And it is only taking up 121 MB. But then why is that Golang image which is taken, using the Debian image as a base, taking up so much? Because it has all the development tools, Go packages, Go runtimes, everything is added into that image. But to run that main program that we created, I think there was a question. Okay, I'll get to that question. Give me a moment. I'll just finish explaining this. Okay. Now, what happens is we added all those like tools and build kit, Go build, Go runtime, everything into that image, and that is why it is bloated to 838 MB. And now then we added our own application to it, which again is a small this one, right? It shouldn't ideally take so much size, but when you build something, it could also create some temporary files and other things, and it will add to the size. That is how, like, from 830 MB also it went to 866 MB. But at the end of the day, what we are going to run is one binary. We don't care about anything else. So we don't need this much size, right? It actually impacts, like, our disk size, our memory pressure, how fast your container starts. Everything is impacted by the size of the image. Okay. So there is a workaround, not a workaround, an actual solution for this, because there's a real problem. So there is a standard way to, like, fix this. That is called multi-stage build. When you say multi-stage build, what happens is, in one stage you build the software, then in the second stage you take the software you built and put it into a smaller image, and then you use that for, like, running running the, like, the service basically. Okay. So we are just going to see that, and then further, if required, we can install. But let us see the another Docker file. Okay. So there's another Docker file here, which is a little different. Okay. So if you see here, right, the first 5 lines are exactly the same as, like, before. Okay. Not exactly the same. You will see a small change here. Okay. I'm just going to do like, put it side here, right? Right. If you see here, this is what happens. If you see here, right, these lines are same actually. This is the original file that we had, and this is the other new multi-stage file we have. This is also similar, but the difference here is that, like, there is a statement called as first build. What is it saying? You are downloading from this, this Golang, image, but when you are done building this image, in this file, in the context of the entire Docker build, I'm going to call it first build. Why? We will get to that part in the bottom, but that is the only difference in the first part of the Docker file. Okay. Now, this is where we stopped in, like, this is where the first part, the normal, like, our build that happened ended, right? Now what happens here? Then there is another from. See, we saw that, like, we were only using one from in the build, our Docker build, right? Now there's a second from argument here, which is alpine latest. What are we doing here? Whatever is the default repo, which ideally is, like, the GitHub repo, sorry, Docker Hub repo, download the Alpine OS image. Alpine is a very lightweight OS basically, and pull the latest image is what we are saying. Then we are saying workdir/root. Again, we have seen workdir before. You are setting a directory there, that this is where I'm going to work, or, like, do my rest of the operation. That is what we are seeing, right? Now, one thing we are seeing is, again, copy is something that we are familiar, because in the first part, what we are doing, copy something from the local to the build, the /KCD Kerala. All those main.go Docker files were copied to this directory, right? Similarly, we are doing copy here. The difference here is that, like, what is the source of copy? -- from equal to first build. From this build, which we did in this stage. This is the first stage. This is the second stage, right? This last 4 lines are the second stage. In the first stage, we build something, and that is called first build. That is the image. Now, from that image, considering that image as the source, not your local directory, considering that image as the source, copy this file into your working dir, which is /root. That is what it is saying. And once you copy it, you run this command .main from that container. Now you remember, this is not entry point, this is command. It will all behave similarly, but again, I'm leaving that as an exercise to figure out, like, why CMD and entry point are different, or, what is the relevance of that. Simple Google search would tell you, but please do that immediately after this, workshop, so that you understand the difference. Okay. Now what happens? We have a new image that we are creating out of this. Okay. So what is our instruction here? Okay. So we are going to again build it. What we are going to do is the -t, right? I'm going to name this image Go App Minimal. That is the only difference here. Okay. I'm going to use this multi-stage build file, and I'm just going to build this. All right. So just quickly look at the command. This is not different from the original command we had, or the build we had. The only thing is the Docker file has changed. We have already explained what is the Docker file, and we are naming it Go App Minimal, not Go App, which was the original name of the original Go App, like image that we built. Let me just run that. Keep an eye on, like, the output. We will come back to this output actually. Let me just All right. Okay. So this is where we started, right? It's similar to like, earlier, you have a step 105, 205, like that it goes, but it also has another column here, right? It says 1 bar 2. What is it? First of the two steps, two stages, right? This is talking about stages. This is a multi-stage Docker file, and we are, Docker is executing the first stage right now. That is what it is saying. And within the first stage, which are the steps that we are executing, right? Again, we are familiar with all these, commands, right? So we know what to do and all those stuff. So this is what it is doing. If you see here, first step, second step, third step, all those things are there, right? One thing you might, if you have noticed, again, there's a lot of output usually in these commands, but if you have noticed this, there's a new line here using cache, right? What does it mean? See, we had already built this image as layers, right? If you remember, we talked about layers, right? These are the layers basically. So if you have a Docker file and you are building an image, every line in the Docker file is a layer basically, which means you are doing some operation. That means, let's say, we took the library/golang as an image. We did one operation in the second line. That becomes, to that image, you added one layer. In the second instruction, you added another layer. So on and so forth it goes, right? That is what layers mean. And now I'm assuming you got at least a practical sense of how layers are there, right? Every instruction or every modification that you do to the base image that you start in the step 1 is a layer that is added on top of that image. That is how it builds. Now, why we are not having, we are not doing this operation again, because we have built the same image already. We have it locally available as layers. Now Docker can pick layers and say that, look, I already have this layer with the same instruction, same base image already. I'm not going to run this operation again. I'm just going to take that image. And that is why, it is using cache. Okay. This is another optimization that Docker does for, speeding up the builds. You already have something built and most of your layers are the same. It won't, do anything, and it won't, redo the operation again. It will just rather take it from a local cache. Okay. So that's why you keep seeing, cache for up to all the, work in the first stage. Okay. Now, we went this 2 bar 2, which means this is the second stage of the multi-stage build, right? 2 bar 2, what is the first step? From Alpine latest, we are just downloading the the Alpine latest because we didn't have that locally. Now we downloaded it, right? And then we, of course, we went into the next layer of doing stuff work layer. Again, this is a new layer. Then we did this thing, new layer. At the end, we did a commit to go up minimal, which means ultimately it created a local image. Okay. All right, so we are here now. So we built this. Again, I'm going to see what are the images here, right? Oh, interesting. We have seen all these things here, Debian, Golang, how much space it takes, and the Go up it takes. These three we are familiar with, right? These three we are familiar with, right? Now what you are seeing, Alpine image in itself, right? When I downloaded, it's only 7 MB. See the difference? It is just 7 MB, right? Sorry. Okay, it's only 7 MB. Now I created a Go up minimal, right? What did I do? I used this image to build the app, then ignoring or ditching this thing, I took that latest built binary or the artifact only, because that is the only thing I need. I took it from that image, put it into another Alpine image in the second stage of the build, and then I created the image. Now see what is the size? It is 9.47 MB. Obviously, this is quite useful, right? Because the size is, you can see the size is huge. Now forget even Alpine, right? See, this Golang image was actually built from Debian. Let's say you want to build with Debian. What would have happened? Your in the second stage, if you had given instead of Alpine, you had given Debian here, it would still have built and it would have been probably 130 MB, which is still much better improvement, right? So this is why you should have multi-stage environments. I don't know how many of you have used Java applications. I'm assuming most of you have. Let's say you have a Java application. Let's say you have all these jar files, not even jar files, your source files and everything here, and you want to build a Java application, which will finally result in a jar file, right? So to build that Java application, you need a JDK, Java Development Kit, okay? Which is a whole bunch of tools for building Java programs. But if you want to run jar or the final product of that build in the production, you don't necessarily need the entire JDK. You can run it with JDK, but all you need is JRE, which is a much smaller runtime environment, Java runtime environment, and with the JRE and the jar, you can actually run a Java application, right? Now think of that like, you took a Debian image, put all the, JDK, runtime build tools. You will probably use Gradle as a, build tool for like, your Java application. You put all that thing, the image from 128 MB went to like, 1.5 GB. And then you put your source files in that. Again, your source files will be a lot, but when you build it, you will just get, the output is, let's say, finally a single jar. Now, in a multi-stage environment, you can do all these things. You probably, by this time you finish it in the first stage, your image is like 1.5 GB because you have all the SDK, temporary files, source files. At that point in time, you take that jar from that, put it into the basic, Debian image, which is 121 MB. It will probably be 150 MB. It is an optimization. Now, there could be like, software, so like, you have to do this through multiple stages. You have to do some compilation, you get an artifact, then you have to use some OS, some other tools in some other, container. So you can have a number of like, stages, and like, it can go through all these stages. Whatever containers are used in the intermediary stages are not used in the final product. So that way you get a huge optimization in container building. Okay. Okay. So I see some of the folks leaving, so I will speed it up. But actually, we are towards the end of the like the program actually, right? Now, what we are going to again, I'm assuming you got some idea about the layers as well. I don't know who asked the question. I'm hoping you got some idea about what layers are. Of course, this is an introductory class, so please go and like you had a question or you got it?
Yes, okay. So right now we are building an image, creating the image from Docker image and building the file and moving that source to another image and running it, right?
Correct.
So
Yeah.
is it possible, imagine if I already have the output file, already built the Docker file and I have the output. Is it possible for me to push that image, that executable from here to the image?
Yeah, so in that case,
skip
you are
the
just
first
going back to
stage.
yeah. So in that case, you are just, it is just like this one. Na? Let's say, we'll go to Docker file. Let's see. Let's say I have this main file already, right? You are saying that like, you did this go build main.go already.
Yes,
right?
yes, I already have the output.
Locally on your laptop.
Yeah.
Which means you have a binary called like, main already with you, right?
Yeah.
You already have that main file. Now, all you have to do is, you are in this directory, your Docker file will be from docker.io/library/ you don't need Golang. You will say like, Debian or Alpine. Alpine is 7 MB. That is all you need, right? So you say that like, from docker.io library/Alpine. Then next line, you say copy main/KCD Kerala entry point /KCD Kerala/main, and you are done.
Okay. Got
it.
Good.
So that's what you do. So all you are doing a copy, right? That's all you need to do. And then you can do Docker run, your image. That's all. Okay.
Got it. Thank you.
Fantastic. Okay. So we are getting to the final, part of, this one, right? We talked about, mentioned that like, we will be covering security as well, right? Now, there's a lot of security aspect, running the container themselves. We talked a little bit about like, how you can control resources, how, Docker runs as like Docker daemon runs as a root, and like, Podman doesn't use root, which adds some more security, those things. Now, the security you're talking about here is a little different. Let's say you have your code, right? You might have your code. The code might have some vulnerabilities, software vulnerabilities. The Docker container you have is a noise-based, Docker container, which might also have a lot of packages which are like, having vulnerabilities, right? Now, there are security tools which can tell you like, okay, this particular package has some vulnerability. You have to upgrade it, right? Now, what, some of these container image scanning tools gives you is the, ability to basically like, scan your code and your image and say that, look, there are the, this many, vulnerabilities are there. Okay. So I'm just going to use an open source tool here. Okay. And okay. So essentially, I'm just setting a new repo. This is an rel thing, basically. I'm just setting up a repo. Install Privy is like, a security. I think this is provided by Aqua Security, right, Srijit?
Yeah, it's still an open source tool, not acquired by anyone. It's still an independent company, but very popularly used in many of the CI/CD pipelines in terms of image scanning.
No, I was talking about not acquired, aqua security, right?
Yeah, oh, yeah. Sure. Yes. Yeah. I heard it as acquired. Sorry for that. Yeah.
So it's aqua security, which is a security company, which is famous for
Right.
they have published this like
Yes.
correct. Now what we are going to do is we are just going to bring in a new image. Okay. CentOS is another image, right? Now what Trivi as a CLI does is again a security tool, right? I'm just going to run it here. So we already have the image available locally. My command is quite simple: Trivi image as CentOS. Now Trivi is going to look for vulnerabilities in the CentOS image. Okay. Let's see how much time it takes. It takes a bit of time. Okay. So it does a whole bunch of things, not just this basic vulnerability. There are other things it does. Okay. There's a lot of output. Let me just go through it. Okay. So what is happening here, right? You see here, let's just take one line that I just want to reach the top of it. But it's a huge one. Okay. All right. So what are you seeing here is we still are not at the top of the report. Let me just open it once again. Sorry about that. And I just want to really show you this one. So just going to run it once again. Right. So what you see here, right? It scanned the entire image. This is the summary of the report. It ran, found a lot of vulnerabilities. One is unknown, one is of severity low, one is of medium severity, one is high severity. There's no critical severity software problems here. So what does this kind of tools do? Trivi is not just the only tool. There are a whole bunch of other tools, right? What does they do is they have a standard database of vulnerability, packages on which vulnerability is found. Now what it does is it downloads the database. If you saw the start of this command, I think that output went away, but let's say it was downloading a database actually of vulnerabilities. And then it went through the entire image, looked at all files and packages, did a comparison with the database and said okay, look, this particular package or this particular file is affected by some vulnerability as per our database. You should be upgrading it if there's an upgrade available. But it's calling out that there are some security issues. Okay. So if you see here, right, to the first line, bind export libs. This is a package. Bind is of course on the DNS service actually, right? So bind export libs. CVE, this is a number of common vulnerability database from common vulnerability database, which means this is this is a standard entry. You can, if you search for this number, you can actually find this in an online database. What is this vulnerability? The severity of this vulnerability is high, which means it can be quickly exploited. And which version is installed on this CentOS container? This version. What is the status of the vulnerability? It is fixed already in the open source community, and the fixed version is this one. And there is some explanation here, what exactly is this package and what happens and all, right? Now, if you search online or go to this link, you can learn more about this vulnerability. But the summary of the matter is that this is a high security vulnerability. It is for this particular version of the package which is available on the CentOS image, and it has a fixed version which should fix your problem. And like that, there will be a whole bunch of lines here for a lot of services, right? See, you can keep seeing this. If I remember it, we had around 1,900 lines actually. So this is just giving it as a table. You can also generate this as a JSON file, export it somewhere, use some other tools, analyze it, or make a report. All those things are possible, right? So that is the whole idea of image scanning. See, right now you are scanning it in your what you say, your local file, right? What would typically happen is when you are actually deploying something into production, you will have a CI/CD pipeline using Jenkins or some other tools or some cloud build tools using which you will ultimately start building your containers. Now when you do that, if you also include a step where you can, let's say, install Trivi and run it against a container, your container, and then let's say does a bunch of checks. It generates a report, obviously, right? You can scan that report, or there are other tools which can report that saying okay. And then you can make a policy or decision saying that look, I see 20 high level vulnerabilities. Let me patch them first. And let's say for this vulnerability, I'm just going to update this package. So this is going to I'm going to put this into my Docker file. I'm building it new, and then I will push the use that new image. so that this vulnerability is patched before my service goes into production. That is the whole idea of this scanning. Again, we showed a very miniature version of this thing, but this is how ideally container security for your code and your containers vulnerabilities usually works. Okay. Do we have anything else? Yeah, again, there's a command here. I can put it here actually. Just going to, this is the last command of the, this one. Okay. Yeah, again, if you see, okay. Okay, I don't know what exactly happened, but yeah, this was some of the warnings. But if you see here, you would see a new file here. So again, why do we show this here? You can actually process this file. See, it shows a whole bunch of data basically. It's whatever you saw as a tabular form, it is showing as a JSON now, but with much more detailed things, right? It talks about what exactly is the errors that you got, what files have these issues, stuff like that, right? So it gives you a whole bunch of ultimately what is the purpose? You got this report, you can make some decisions based on this report whether my application is good or not, and then take a decision to go forward or fix these issues before you go forward and deploy your application in the production. You got it? So with that, we come to the end of this workshop, and of course, I know we took a lot more than we said, in the original description of the event. But again, this is what happens when we have a discussion and things goes on. And thanks a lot for all of you who stayed behind. Now I'm open to questions. Feel free to ask the questions here, or if you want to ask questions later, I think we can facilitate.
Yes, Safir, we have an interesting question from Mr. Jalil.
Okay.
So probably you can read it yourself. Yeah.
Is it in the chat?
If the last one, if you are running multiple applications using containers in a server, are you seeing that question? Can you see it?
Yeah. If we are running multiple applications using containers in a server, does that mean every application will have all the required dependencies duplicated in each respective application directory? True. When you say dependency, what exactly is that? Would you mean? Are you saying, let's say, you are running a 3 or 4 softwares, which all of which uses, let's say, some Java package. If you are on a server, you could just have one package, installed, and then you can run 5 instances of your application. Is that the question? Jalil, if you're around.
Yeah. Yes. That's good. So I was thinking we created this Golang app, right? The Golang app, something you named, and you have something similar, Golang app 2, which also uses the Ubuntu. So you have separate directory for both this application, and they are using the same version of Ubuntu, but you have this in separate application directory. Means it's kind of like you're taking more space, right?
Totally right. Actually, it is very very true. Let's say you have 2 applications. Let's say application 1 and application 2, right? And you want Ubuntu containers for that. If you are running 2 applications, both of them are going to use Ubuntu containers. Now we saw that Ubuntu containers 80 to 90 MB. So each of your applications would take up additional 90 MB. See, application sizes anyway, you cannot do anything with that. But you are going to have 2 separate images, right? Why we are having that? Tomorrow, if your dependency changes, you don't have to worry about using the same container, right? The idea is that you have one process. Your ultimate purpose is to run one process at a time independently, without worrying about any sort of dependencies and any other security or access issues of where it is running, what is the adjacent service, things like that, right? So that is why we have this. That is the cost of what you say, isolating your images. So it is true, it is going to have a duplication of that base OS part of things, but that is the cost we will have to use for this bifurcation and the other benefits of managing dependencies independently. Let's say today today what you said is correct. Let's say both are using Ubuntu as a base image, but they are also using some other additional what do you say dependencies, right? There is one XYZ package that I have to install. Your application 1 is dependent on XYZ 1.1, and your new service, the second service that you wrote, is dependent on the same package but of a different version, 2.2, right? If that is the case, At which point you have a digression, right? You have two different set of dependencies. That is where this kind of things comes into picture, right? In those cases, you will have to use you will ultimately have two set of container images, right, which are different. It is not same anymore, right? Even barring your application code, even the other part, the dependencies, other bases, everything is different, right? That is the advantage that containers offer you. That your dependencies, anything that is related to your application, is all in a dedicated environment, contained. Right. So again, this is unavoidable. It will be there. That is an additional cost we are paying, but it also gives you additional flexibility where to move your dependencies or applications from one server to another without worrying about what is underneath. As long as you have a Linux machine with a container runtime or a container engine running on it, you can take your applications from machine A to machine B or machine 20,000. Right? It won't make a difference. That is the whole idea. Does that answer your question?
Yeah, it does. It makes sense. Yeah. So it's kind of like
if I have to use a single word, it is portability, right? Portable from one place to another.
Yeah, that makes sense. Yeah.
Cool. Any more questions, folks?
So there were some questions which I believe I answered in chat, but in case you want to add something to that, please go ahead.
I saw a YAML question. Was there anything else? Running multiple applications. Okay, that is done. YAML was the.
Yeah, I think Husni Samina had a question whether the Docker file content will change for different project. I think she was referring to the instructions inside the Docker file, for which I responded, yes, it should change based on what you want to build.
That's right. See, at the end of the day, what is a Docker file? Right? It is just telling Docker that, look, I have these dependencies. My base is going to be this image. See, all Docker files start with what is my OS base, right? But then it says look, I need this 10 things from this repo. I want you to do these 3 actions. I want to install 4 Ubuntu packages as a dependency for this application, so on and so forth. And then finally build my image. That's what you're going to tell the Docker, right? So depending on your application, the instructions will keep varying. Everything will have a from in the beginning. That is one thing that doesn't change, but that might change. That might be different. Let's say you are just deploying a Golang file, which is just a binary. You can use Alpine. But let's say you are deploying a Python application. Now there is a small problem. Alpine and Python doesn't go well together because Alpine is such a trimmed down, and it uses different glibs. It uses a different C library basically, which is a foundation for all the Linux OSs. It is called glibc in most of the Linux operating systems. But Alpine uses something called Muscle, which is a very small equivalent, C library implementation. Python doesn't work very well with that. So if you put a Python application in an Alpine container, it won't work. Like that, there could be a lot of nuances like that. So you will have to pick your right image. You will have to put all your instructions and put everything in the Docker file. See, think of this like your application build script file. So I don't know, there are for Java you have Gradle files, C you have make files. Think of it like that. Instead of running just building your binary, you are building a container at the end of the day. But what exactly are the instructions going into it depends on your application's workflow. What are its dependencies? What are the steps to follow to set this up and run this inside a container, right? So the instructions will keep changing. But that's why there are limited set of keywords or command Docker keywords that will be added to a Docker file, so you can learn them and you can mix and match them. See, at the end of the day, this is all about move this file from here to there, set this entry point, run this command, things like that. Quite simple things. Even if you have a make file or a Gradle file, this is what most of the build systems do when you are building something, whether it's the C++ program or Java program or container. It is like that. Just like you have a make file for C or C++, you have a Docker file for a container. That's all. And the instructions will keep changing. I think I blabbered out a little bit more, but I was hoping that that answered the question. Cool. Any other questions, anybody?
Yeah, one small question from me. Yeah, so
you any number of questions are welcome.
Thank you. So you earlier you mentioned creating a version and you can say latest there and it will be the latest image. So
Correct.
what happens when we do it next time? So we'll have two latest images, right? You're
Yeah, so
supposed
that's a
to.
see, label can only point to one image. Okay.
Oh,
So you can
okay.
have additional tags. Okay. So let me, I'm
Okay.
just,
So
just
you'll
rather
be
than
specifying
explaining
version
it
and
like,
a label.
yeah. So
Oh,
no, version is the label basically. Let's say, go here. Right? Let's say if you, this is the Debian, like, so this is Docker Hub, where this is what, we were seeing as docker.io. This is the front end for that. Okay. Now this is a Debian image that you are talking about, right?
Yep.
So if I just do docker pull Debian, I will get the latest tag. Okay.
Okay.
Now, if you see here, there's a whole bunch of supported tags.
Oh.
See, latest is here. Latest is associated with, see, each line is basically one image, but you can see that it has a bunch of labels.
Wait,
if I
wait.
use latest,
I think you misunderstood. So I'm talking about when we create an image, like we build the Docker image and all, then we can specify which version that image is, right? Because
Correct,
we
yeah.
need some kind of versioning. So if
Correct,
we
yes.
say latest, then what happens when we build the next image? So it will be the
So
latest
your
one.
latest, that will be the latest image.
Okay, so it will have a version and a latest tag.
It won't have a version. You can only have one tag. That's what I'm saying. See, these are all the multiple tags that you can apply for the same image if you want to. Right?
Okay.
But with one tag, you can only reference one image. That would be like whatever is the latest that you built, right?
Okay.
Now, if instead of latest, you said like your latest images tag is XYZ, it is fine. You can do that.
Okay.
Got it. So again, like in the Docker help, you will get some information about the labels, right?
Yeah.
It has a lot more information about label. See, the Docker, this thing itself is quite like vast actually. Like I'm assuming you can see my browser, right?
Yeah.
Yeah. So image labels. Yeah. Again, I'm not going to the whole document, but you can see it here, right?
Got
labeled
it.
images, right?
I'll just search. No issues.
So a lot of this. Sorry, this is not. Sorry, this is labels. My bad. It is tag. Label is a different thing. Label is basically like adding key value pairs so that like you can add additional metadata to the images. It is not as tag is what okay. When I search type. Yeah. Anyway, you can just search it, right?
Yeah.
Tag,
Thank you. I got the basic idea, so
yeah.
I'll
So
be fine.
again, like it doesn't have to be even when you build. You can additionally tag later also. Okay. There's a Docker tag command actually.
Got it.
Got it. Yeah.
Thank you.
No problem. Any other questions? Anything? I think there's a WhatsApp group for KCD Kerala. Right? I don't know.
Right. Yeah. So we do have. But first of all, thank you so much everyone for staying back. Thank you to Safir also. We know it's almost 9:15 in India. I think we all joined from India, so thank you so much. Yes, Safir, you're right. We do have some exclusive Kubernetes community days, Kerala-based social media handles and WhatsApp groups. I'm just sharing. Oh, I think it got mixed up. But we do have quite a few social media presence. I will actually be sharing the WhatsApp group invite. If you actually think of joining and get involved in Kubernetes related discussions, please consider joining our WhatsApp group. I will just share that right away into the Zoom chat. Here it is.
Actually,
Yes.
I think you have their emails, right, Srijit? When they register for the workshop, we got their emails, no?
Yeah, we have their emails.
Okay.
Yeah. So I think because especially because we have a bunch of participants who dropped off already, right? If we email them with all our social media handles,
Right. Yeah.
So from here clicking and joining WhatsApp group may not work for everybody if they don't have WhatsApp web open, right? So we can just email them and we'll be happy if everyone of you join and
That's a great suggestion, Safira. Humble, I think I made a note of it. Okay, we will reach out to them with these details. But like Humble asked, We hope you learned something new today. Those who already knew about containers but wasn't working in containers for a long time, I think it was a refresher for you. But truly appreciate your time staying back and asking questions. We believe that when you do something, you get to know about it the most. So that's why we opted for a demo slash workshop slash hands-on kind of a model. We will also do more workshops in next year, that is in January first week, then third week. Just to remind you, the Kubernetes Community Days Kerala event happens on Feb 3rd, Saturday, at Meridian, Kochi. So if you are interested or if you have friends who are interested, please spread the word, register yourself and be present there and network and learn all good things which happens in the container and Kubernetes world. Yeah.
And I appreciate all of you who keep listening to the whole rant I was doing for last 2 hours. I hope
Yeah.
it added some value to you. And please send your feedback, good or bad, and we would like to improve.
Yeah.
We would
Yeah.
like
Yeah.
to helping each other.
Yeah.
Yes.
All right. So any final questions before we wind up?
So the workshop that you're going to conduct in February. So what kind of level of expertise you're expecting from the the participants?
Jalil, the February event is more like a technical presentation kind of a event. We will have 3 tracks. One is the core Kubernetes, then second DevOps, and third security. Most of those actually has something or other related to the Kubernetes orchestration tool. Okay. So the level of expertise is, if you are interested in containers or starting your journey into container orchestration, especially Kubernetes, I think that will be a great place to network with other like-minded people in Kerala. So the expectation is some level of understanding of containers and Kubernetes. Even if you are very new, there will be beginner-friendly talks which will be presented in that event. But most importantly, you'll get a chance to interact and connect with other technologists who are working in the same field during that event. We are targeting around 550 plus attendees across 3 different technical tracks.
Okay, thank you.
Jalil, before the event, the main event, which is happening on February 3rd, we will have a few workshops in Jan, like maybe a couple of virtual workshops like this and a couple of in-person workshops. And then February 3rd is the main event at Meridian, Kochi. That's an in-person event. Yeah, as it was mentioning, like 500 people or 550 people they're expecting, and there are 3 tracks, and almost 35, 40 speakers are coming down. So it's going to be a great event.
Yeah, you can click on that KCD Kerala.in link which has been shared. We have the speaker details already up. We will share the what do you call the agenda fully in coming days, probably in 2 days' time, so that you can see the tracks, see the speakers, see the sessions they are doing, and then make an informed decision. Okay. Yeah.
Okay. Yeah, I already registered for that, so I just wanted to.
Okay.
check
Perfect.
that.
Perfect. So see you on Feb 3rd, Jalil.
Yeah.
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 Okay. So thank you so much. It's just 3 minutes away from 10 p.m. Thank you so much, Safir. Again, truly appreciate almost 3 hours. We know that you are traveling tomorrow, so thank you for your family as well for loaning your time for us for 3 hours. Okay, but otherwise, it was great to have you all here. Have a good evening, good night ahead. See you in the future workshops. Thank you so much.
Yeah. Thank you, everyone. Good night. Bye-bye.
Bye, folks.
Bye.
Thank you. Bye.